Welcome back to Computer Applications 2. In this chapter, we will learn about MATLAB mathematical functions, and we will continue using the command window as a calculator. MATLAB contains many predefined elementary and special mathematical functions. You can browse the documentation of those functions by typing help space ELFUN for elementary functions and help space SPECFUN for special function. MATLAB also provides many predefined values, like pi. We can type it as PI, small letter case, and imaginary units. MATLAB uses the letters I and J for that function, and for infinity we write capital INF. We can use the command window to type an equation for MATLAB to solve for us. We start by defining the known variables first, followed by the equation. For example, let's initialize variable x as 3, variable y as 8, variable z as 3. Then we start typing the formula or equation. For example, we write z equals to exponential minus z parentheses multiplied by the sine of x plus 10 multiplied by the square root of y. And that's our answer. MATLAB contains many other predefined functions like log, for example, and even log base 10. We write it log 10 parentheses and the number we wish. Even sine, and cosine, tan, all of the other functions that you find on your normal calculator, MATLAB can do it. MATLAB uses radians as its standard unit. Be aware of that. You can convert radians to degrees by using the command rad to degrees, and in parentheses we provide the number we want. For example, pi divided by 2, which is 90 degrees. We can calculate degrees from radians by flipping the command around, saying degree equals to rad, and in parentheses we provide the number. We provide the number of degrees we want to convert to radians. MATLAB also contains plotting functionality. The most basic graphical option is the 2D plotting procedures in MATLAB, where you have to create a vector coordinates for both x and y, and then give the command to plot x and y. Let's create an example here by typing vector x equals to, when we type vectors, it must be inside square brackets. It's very important. And we can separate the numbers either by a space or with commas. I can do the commas in y. I'm gonna say -5 to 8, -4 to, and then we provide the function plot in parentheses x comma y. This will plot y over the x-axis. So when I press enter, give it a second, and a graph will come up. You can see, as we said in our vectors, when x equals to 1, y equals to -5. When x equals to 2, y equals to 2, and so on and so forth. Another useful MATLAB function is creating linear scales. By providing the start number and the end number, MATLAB creates a vector of 100 evenly spaced points between the start and the end numbers. We can also specify the increments we wish MATLAB to divide the space by providing the increment number. For example, creating 100 evenly spaced points between 0 and 10. We type g equals to, g is just a variable name that I picked, len from linear and space, all one word. In parentheses we type the start point, for me it's 0, comma, and the end point, 10. When we press enter, MATLAB returns 100 evenly spaced numbers between 0 and 10. We can provide the increments by adding the increment number on our previous equation. At the end, we want to say we want 10 evenly spaced points between 0 and 10. When we press enter, MATLAB returns 10 points between 0 and